Students will be discussing something called as today bond enthalpy. Discussing something called as bond enthalpy. Important है. We'll be discussing something called as Hess's law of constant heat summation and all that. ते जे काही important आहे मी सांगत जाईन. पहिला bond enthalpy आहे का students? You know, if you look into a chemical reactions, each reactant and the products which are in the form of molecules are bonded. The atoms are bonded by covalent bonds. Now what is bond enthalpy? It is the enthalpy change required. बाहेर करायचं, definitions आहे तसे बाहेर करायचे with examples. It is the enthalpy change required to break a covalent bond in 1 mole of gaseous molecules to form gaseous atoms or radicals. I'll repeat, what is bond enthalpy? It is the enthalpy change required to break a particular enthalpy change required to break a particular covalent bond in 1 mole of gaseous molecules or gaseous molecules to convert into atoms or radicals is called as bond enthalpy. Students, point number 2, bond enthalpy of polyatomic molecule. बघा हा, bond enthalpy of polyatomic molecule. एक साधा example घ्यायचा, job is over. For example, water molecule. You take the water molecule here. Water molecule is bonded by, if you take H2O, it is bonded by 2 OH bond, OH and H, like this. असा असतो तो, HOH. The water molecule consists of 2 OH bonds, 1, 2, which are covalent bonds here. So, if you take water molecule, how are you going to show the bond enthalpy? Please concentrate here. Take water. Take water molecule. हा एक polyatomic है because it consists of hydrogen and oxygen. Take water. Water dissociates into 2 atoms, that is hydrogen and oxygen. ठीक है? The enthalpy change of the reaction. The enthalpy change of the reaction is given by round about 927 kJ. आता तुम्ही म्हणा actually हे reaction कसं घडतं? How are you going to represent this enthalpy change in terms of bond enthalpies? I'll show you how you show. Step number 1, H2O giving rise to what? You get H plus OH. The corresponding enthalpy of the reaction. The corresponding enthalpy of the reaction is 498 kJ. ठीक है? Then step number 2, OH bond. OH bond 499 kJ. Look here. The OH bond breaks into what here? Here you get O plus H. The corresponding enthalpy of the reaction is 428 kJ. When you add both of them, what do we end up with? Concentrate. So the net bond enthalpy of the reaction is what? H2O. This OH products, we'll put it like this. Reactants minus products. What do we get? OH, OH cancels. H plus H on the same side. Add होतात opposite side. Minus होतात plus O. The overall enthalpy change of the reaction is 927 kilojoule. परत रिवाइज करायचं, कधी सांगताय, whenever they ask you any definition, students, please give a typical example. What is bond enthalpy of a polyatomic molecule? Bond enthalpy is the enthalpy change taking place to break, or enthalpy change required to break a particular covalent bond in 1 mole, एक मोल घ्यायचा, of gaseous molecule into gaseous atoms or free radicals. For example, take water. Water dissociates into hydrogen and oxygen. ह्याची bond enthalpy form मध्ये कसं लिहायचं? H2O, H plus OH corresponding enthalpy is 499. OH breaks further into this, so we get H2O is equal to H plus H, 2H, O as it is, OH opposite sides ला असल्यामुळे ते balance. Net enthalpy of the reaction is what? 927 kilojoules. Are you okay here? Are you okay, students? This is bond enthalpy. After that, generally for a bond enthalpy and reaction, bond enthalpy and reaction, bond enthalpy and reaction. Look here. What is that? Please concentrate here. Bond enthalpy. Students, the net bond enthalpy of the reaction is, standard enthalpy of the reaction is the bond enthalpies of summation of bond enthalpies of reactants minus summation of bond enthalpies standard form of products. See, whenever you show the bond enthalpy of a given chemical reaction, it is the overall enthalpy of the reactants minus enthalpy of the products. 0 0 म्हणजे in their standard form, means the pressure is 1 bar and the temperature is 298 kelvins. That's it. कळलं आता? Okay, and all the substances are in the natural form, like hydrogen in gaseous form, carbon dioxide in gaseous form, and so on. Now I'll show reaction here. See students, तुम्हाला माहिती आहे H2 hydrogen reacts with iodine to form hydroiodic acid or hydrogen iodide. How do you write the bond enthalpy of this reaction? We write net bond enthalpy of the reaction where the reactants and the products are in the standard form is given by summation of H delta of HH plus summation of delta II minus summation to HI. कळलं? Summation to delta HI. काय लिहिलं आपण? Reactants are what? A hydrogen molecule bonded by 2 hydrogen atoms, iodine, 2 iodine atoms, and HI 2 delta HI. That's it. Are you okay here? This is bond enthalpy under given chemical reaction. आता clear मुलांनो? हाँ? Is it fine with you? Yes? हाँ. आता what we are going to discuss the next part is a very important part which is called as Hess's law of constant heat summation. मी तुम्हाला ते परत शिकवते हा. That part is very important, students. What is that? Please look. Hess's law, spelling बघा, HESS apostrophe S. Hess's law sorry, Hess's law of constant heat, Hess's law of constant heat summation, IMPA. What is the statement? The overall enthalpy change of a given chemical reaction is the enthalpy changes, sum of the enthalpy changes of individual, individual components. I'll repeat. The overall enthalpy change of a given chemical reaction is the sum of the enthalpy changes of individual reaction, individual components. Point number 1. Point number 2. The enthalpy change of a given chemical reaction remains as it is. Enthalpy change remains as it is irrespective of the path followed by the reactants to get converted into products. म्हणजे कुठलाही path follow केला तर overall enthalpy of the reaction is constant. Point number 2. Point number 3, which shows that enthalpy is not a path function, it is a state function. Point number 3. Point number 4, neat ऐका हा, it's not a path function but it's a state function. एक झालं. नेक्स्ट स्टुडंट्स, आता टू शो दॅट if you represent a given chemical equations, what is it? A given chemical equation is the sum of the reactants and products involved in that chemical equation. For example, look here, दाखवते हा. आता तुम्हाला एक जनरल रिएक्शन, बेयर्स प्रोसेस चा जनरल रिएक्शन माहिती आहे. हा तुमचा जनरल केमिकल रिएक्शन. Nitrogen and hydrogen react to form ammonia. Okay, how does this take place? How do you show the constant Hess's law of constant heat summation? Here nitrogen reacts with H2 to give rise to, add करते N2H4. The enthalpy change occurring in the reaction is equal to what? Enthalpy change occurring in the reaction is what? It is round about 95.8 kg. Second, now what happens here? N2H4, second, step number 2. N2H4 reacts with one more hydrogen to form what? To form NH3, and that also how much? 2 NH3. The enthalpy change of the corresponding reaction is minus 187.6 kg. Hence, add करा, what will happen? Hey, hella surprise or cancel out. What do we get? Therefore, N2, 2 plus 2, 2 plus 1, 3H2, giving rise to 2 NH3. Overall enthalpy of the reaction is what? Add करा. Actually, you have to subtract it म्हणून. 16 minus 8, 6 minus 5, and round about 18 minus 9, minus 91.8 kg. That's it. Are you okay here? Are you okay? Is it fine with you? I'll repeat it again. हे मात्र इम्पॉर्टंट आहे. काय काय पॉइंट्स लिहायचे तुम्ही लक्षात घ्या. Hess's law of constant heat summation states that the enthalpy change occurring of an overall reaction is the sum of the enthalpy changes occurring in sum of the enthalpy changes of all the individual components involved in a given chemical reaction. Second point, enthalpy change of a given chemical reaction always remains constant irrespective of the path followed by the reaction. म्हणजे enthalpy ही path function नसून स्टेट फंक्शन आहे. पॉइंट नंबर 2, फॉर एक्झाम्पल तुम्ही कसं एक्सप्लेन करणार हे बघा. Hess's law of constant heat summation, N2 plus 3H2 overall reaction 2NH3. How do you divide it into parts? N2, N2H4, it's a typical intermediate product जे constant राहणार म्हणून, and that is how the ammonia is formed. The enthalpy of the reaction is only a state function and not the path function. मग कसेही कुठल्याही पद्धतीने तुम्ही जरी घेतला, if you take it directly by the Bayes process or in these steps, the enthalpy of the reaction will remain as it is. That's it. This is called as Hess's law of constant heat summation. Are you okay, students? Yes. Go to the next process which is regarded as most important, that is what is a spontaneous process. Spontaneous process, very important. Spontaneous process is a process, it's a natural process which takes place on its own, irrespective or we can say without any external stimulus or external force acting on it. That is called as a spontaneous process. Point number 2, spontaneous process occurs in, म्हणजे what is a spontaneous process? Point number 1, it's a process which occurs on its own irrespective of any external agent acting on it. कुठलाही एजंट खाली न ऍक्ट होता the process which takes place on its own, spontaneous process. त्याचे पॉइंट्स काय काय लक्षात ठेवायचे. Spontaneous process occurs in a given direction. Spontaneous process occurs in a given direction. The process can only be reversed or made to occur in opposite direction by applying any external stimulus. म्हणजे स्पॉन्टॅनियस प्रोसेस ही नॅचरल प्रोसेस आहे विच टेक्स प्लेस ऑन इट्स ओन. पॉईंट नंबर 1. हा पॉईंट नंबर 2 धरू शकतो आपण. इट टेक्स प्लेस इन अ गिवन डायरेक्शन. it takes place on its own in a given direction and can be made to follow an opposite direction only under an external agent. कुठलाही एखादा एक्सटर्नल स्टिम्युलंट्स खाली त्याला रिव्हर्स करता येतं. पॉईंट नंबर 2. पॉईंट नंबर 3. स्पॉन्टॅनियस प्रोसेस कंटिन्यूस until the state achieves equilibrium. म्हणजे काय? The concentration of reactants and products is or the rate of forward reaction and the rate of reverse reaction is same. त्याला आपण spontaneous process म्हणतो, which त्याचं एक इंटेन्शन काय की the tendency of spontaneous process is to reach equilibrium. That's it. परत सांगते, spontaneous process is a natural process which occurs on its own without any external influence. हे त्याचे properties. Point number 1, it's a natural process. Second, it continues only in one direction and you cannot change if you want to reverse it or if you want to make it follow an opposite direction, you have to use an external agent. Third, the process continues until equilibrium is reached. Equilibrium म्हणजे rate of forward reaction is equal to rate of reverse reaction. That's it. ह्याला म्हणतो आपण spontaneous process. That's it. Is it okay? Fine. Yes. Is it fine, students? Yes. We will stop for today. We'll continue some points again tomorrow. Clear? Yes.